Good morning, everyone. Today we will discuss about relationship between pixels. So we know that digital image is composed of pixels, right? So generally the image is represented in matrix form, that is m by n of size, with 0, 1, 2, 3, 4 n columns, 0, 1, 2, 3, so on, m rows. Okay, m rows and m columns. So each one is represented with f of 0 comma 0, f of 0 comma 1, so on, like this, right? Now you have to find out the relationship between these pixels. What is the relation between them? Okay, these relations can be explained in following terms. Okay, first one is neighbor. Neighbor. Second one is adjacent. Third one is path. Fourth one is connectivity. Next, a region, boundary. Next, distance measure. Distance measure. Edges. So these are the basic relationship between distance measures between two pixels. Okay, these are the basic relationship between pixels. We have to explain everything. So in that, first one is neighborhood. Neighbor. Suppose two pixels I am considering P and Q. Okay, Q is said to be neighbor for P if the distance between them is 1, that is unit distance pixels. Unit distance pixels are called neighbors. Okay, so these neighbors are classified into three types. Okay, four neighbor denoted as n4 of P. Okay, four neighbor means unit distance pixels which are at horizontal and vertical axes. Okay, next, eight neighbor, sorry, diagonal neighbor. Diagonal neighbor is given as ND of P. Unit distance pixels which are at diagonal axis. Okay, next, eight neighbor is denoted as N8 of P. N8 of P is combination of all pixels. N4 union ND of P. Okay, combination of all pixels. Let us see one example. Okay, now I am taking a group of pixels like this. Okay, I am taking one group of pixels like this, 3 by 3. So I am considering this is as P. Okay, this is as P. So denoted with X comma Y. So unit distance pixels I said. So this is X axis, right? And this is Y axis. So Y axis next one is we represented with Y plus 1. This is Y minus 1. X plus 1, X minus 1. So then what are the notations of these positions? See, X plus 1 comma Y minus 1. This one is X comma Y minus 1. This is X minus 1 comma Y minus 1. This position is X minus 1 comma Y. This one is X minus 1 comma Y plus 1. This one is X comma Y plus 1. Because see, this is X axis and Y axis is represented with Y plus 1. Next, this one is X plus 1 comma Y plus 1. This one is X plus 1 comma Y. Okay, because I said the pixels must be unit distance so that we can notate, identify the n neighbor, 4 neighbor, 8 neighbor, diagonal neighbor. Okay, now this is P. N4 of P is represented with horizontal and vertical pixels. See, this is horizontal. Blue color notations are horizontal and vertical pixels. Horizontal and vertical pixels. So what are the positions of them? X plus 1 comma Y, X minus 1 comma Y, X comma Y minus 1, X comma Y plus 1, right? These are the 4 pixels. First, second, third, fourth. Okay, this is N4 of P. Okay, this is N4 of P. Next, ND of P. ND of P I am represented with red color. Okay, see, diagonal axis. The pixels which are unit distance in diagonal axis. So this one, this one, this one, and this one. These 4 pixels are diagonal pixels. So I am represented with like this. X plus 1 comma Y minus 1. X plus 1 comma Y plus 1. Next, X minus 1 comma Y minus 1. X minus 1 comma Y plus 1. So these are positions. Pixel positions. I am represented the pixel positions. Okay. Next, N8 of P is N8 of P is union of N4 and ND, right? Union of N4 and ND means all 8 pixels will come here. So X plus 1 comma Y, X minus 1 comma Y, X comma Y minus 1, X comma Y plus 1, X plus 1 comma Y minus 1, X plus 1 comma Y plus 1, X minus 1 comma Y minus 1, x minus 1 comma y plus 1. So these are 8 pixels. Okay. Let us consider a small example. I am taking one image. 110111101. Okay. I am taking like this. Okay. I am taking this one as P. This one as P. Then N4 of P is equal to what? N4 of P. Horizontal and vertical. This one, this one, this one, this one. So 1 comma 1 comma 1 comma 0. Okay. These are N4 of P. Okay. Next, ND of P. ND of P means diagonal pixels. So diagonal pixels. So diagonal pixels, what are there? 1, 0, 1, 1. Okay. These are diagonal pixels. Next, N8 of P. N8 of P means N4 union ND of P. That means 1 comma 1 comma 0, 1 comma 0 comma 1 comma 1. So these are the neighborhood pixels. Suppose now I am taking this one as Q. This one as Q. Now calculate N4 of Q. Now calculate N4 of Q, ND of Q, N8 of Q. N4 of Q, ND of Q, N8 of Q. So this one is Q now. For this Q, horizontal pixels and vertical are. So this is one, this is one. Horizontal and vertical. There is no other direction pixels because this is available at edge. This is available at edge. So N4 of P or what? No, N4 of Q or what? This one and this one. 1 comma 1. And ND of Q is diagonal value is only 1 is available. Only one diagonal is available. There is no other diagonal. So it is 1. N8 of Q is union of these two. So 1 comma 1 comma 1. Okay. This is how to calculate neighbor. Okay. Based on this neighbor, you have to identify the adjacency. Okay. Adjacency. If you understand the neighbor, you can calculate the adjacency. Okay. Adjacency. 2 pixels are said to be adjacent. 2 pixels P comma Q are said to be adjacent if P comma Q belongs to V, which is predefined set, which is predefined set. Okay. Predefined set, and V belongs to, V must be in range of 0 to L minus 1 only. Okay, the image range 0 to L minus 1. The values of available in V set must be in 0 to L minus 1. And P comma Q must belongs to V. Then we define the first for adjacency. For adjacency. For adjacency means Q is said to be, Q is said to be 4 adjacent. Okay, 4 adjacent to P if Q belongs to V and Q must belongs to N4 of P. Okay, Q must belongs to N4 of P. Okay, second example, second one. 4 adjacency afterwards, 8 adjacency. 8 adjacency. 8 adjacency means Q belongs to V and Q belongs to N8 of P. N8 of P. Then we call it as 8 adjacency. Next, we have M adjacency. So M adjacency is defined in two conditions. Okay. First one is Q belongs to N4 of P. Okay. Q belongs to N4 of P. Or another condition. Either this one is satisfied or this one it has to satisfy. Here, the Q belongs to ND of P. If Q belongs to ND of P, then it also satisfies N4 of P intersection N4 of Q. N4 of Q is equal to pi for P comma Q belongs to V. Okay. For P comma Q belongs to V. Let us see a small problem so that you can understand these three things. So let us consider a small image. Let is V. I given predefined set V is equal to 1 and image as this one. Image I is equal to 0 1 0 0 1 0 0 0 1 0 0 1. Okay, 0 0 1. Now I am considering this one as P. Okay, this one as P because P comma Q must belongs to V. So I am considering this one as P. Now I am finding 4 adjacency. 4 adjacency. What is the definition of 4 adjacency? 4 adjacency means Q belongs to V as well as Q belongs to N4 of P. Okay, Q belongs to N4 of P. Now let us check the horizontal and vertical pixels because N4 of P means what? Horizontal and vertical pixel. So these are horizontal and vertical pixels for P, right? These are horizontal and vertical 0, 0, 0, 1. These are the Qs, possible Qs, N4 of P. Now in the N4 of P, Q must belongs to V. Q must belongs to V. So V is defined as 1. So out of these 4 values, this one is 4 adjacent. 4 adjacent. Means which pixel is 4 adjacent? This pink color pixel is 4 adjacent. Okay, 4 adjacent. Okay. Next. Eight adjacency. Eight adjacency is Q belongs to V and Q belongs to N8 of P. Q belongs to N8 of P. Okay. Let us check N8 of P. N8 of P pixels are what? Horizontal and diagonal pixels. Horizontal, vertical and diagonal pixels means all pixels will come. 0, 1, 1, 0, 0, 0, 0, 1. Okay. All are comes. In these pixels, Q, which of them are Q belongs to V? This one and this one and this one, right? Means I am notating with one more color, that is orange. So this one, and this one. Okay. These are 8 adjacent. Okay. Orange colors are 8 adjacent. 8 adjacent. These 3 pixels are 8 adjacent. Okay. 8 adjacent. Okay. Because the values of Q must belongs to V. Okay. So these 3 pixels only become 8 adjacent. Remaining all are not 8 adjacent. Okay. Next, M adjacent. M adjacent. M adjacency. M adjacency has 2 conditions, right? First condition is Q belongs to N4 of P. Okay. Q belongs to N4 of P. For the same image, I am writing here M adjacency in one more color, that is violet. So I is equal to 0, 1, 1, 0, 1, 0, 0, 0, 1. So according to first condition, this is M adjacent. Okay, because Q is belongs to N4 of P. Okay, this is satisfied. Now second condition. Now second condition. This is satisfied, or Q belongs to ND of P and N4 of P intersection N4 of Q must be equal to pi. Must be equal to pi. Now diagonal pixels are what? This one and this one are diagonal pixels, right? This one and this one are diagonal pixels. Red color. Okay. Now I am taking this one as Q1 and Q2. Now you have to check N4 of P intersection N4 of Q, because you have to satisfy both conditions. So now I am checking N4 of P are what? This is P, right? This one is P. For this P, N4 of P is what? This one, right? This one. What is the position of this one generally? X plus 1 comma y, right? This position. Now intersection N4 of Q1 is also same position, same value came. Okay, I am taking ones only because here predefined set is v is equal to 1. That's why I am considering ones only. I am not considering zeros. Okay, so intersection is available because both ones are belongs to which position? X plus 1 comma y. These two ones are belongs to same position. So intersection is not equal to pi. So Q1 is not M adjacent. Now check Q2. N4 of P position is X plus 1 comma Y. Intersection of N4 of Q2. For Q2 there is no ones, empty set. So total is pi. Intersection is pi. So this condition is satisfied. So possible values of M adjacency are what? Which positions? X plus 1 comma Y and Q2. Q2 position is what? X minus 1 comma Y plus 1. Okay, these two pixels. This is Q, Q1, Q2. Out of Q, Q1, Q2, M adjacency are possible for Q and Q2 only. M adjacency possible. Okay, M adjacency is possible. Because we have to check these conditions as well as these conditions. Okay. Next definition. Path. Next one is path. So path is defined as a curve between two pixels P comma Q. Okay, a line or curve between two pixels P comma Q means by joining the coordinates. Suppose I am considering 1 0 1 1 1 0 1 1 0. So I am taking this is as P, this is as Q. The curve between P and Q. So this is possible curve. This is one more possible curve. This straight line is there. Like this is there. So many different paths are available, right? These are all are called path. A curve between P comma Q. So it can be done in three ways. First one is 4 path. Next one is 8 path. Next one is M path. Path formed by joining 4 adjacent pixels. 4 adjacent pixels between P and Q. Between P and Q. 8 path is path formed by joining 8 adjacent pixels between P and Q. Okay, P and Q. Next, M path means path formed by joining M adjacent pixels between P and Q. Between P and Q. So I am considering one image. 1 0 1 1 1 1 1 1 0. Okay. I am define V is equal to 1. Find 4 path, 8 path, M path between P and Q. So this is P, this is Q. Okay, this is P, this is Q. Now let us see. I am drawing 4 path now. 4 path. 101, 111, 110. So 4 path. 4 path means what? 4 neighbor pixels, 4 adjacent pixels. Here V is 1. So for this P, the possible horizontal vertical pixels are what? These two, right? Now for this one, what is possible 4 path? This one and this one, right? This one and this one. For this one, this is 4 adjacent. Now for this one, 4 adjacent is this one. For this one, 4 adjacent is no 4 adjacency. No 4 adjacent. Because this is 0. Here V is defined with 1. So there is no 4 adjacent. Now for this one, this is Q. Okay. How many possible paths are formed? This is one way. This is one way. We have 2 paths here. 2 paths. Okay. 2 4 paths are available. 2 4 paths are available. Next 8 path. 8 path. 101, 110, 110. So you have to check horizontal and vertical as well as diagonal also. 8 path means. So horizontal, vertical. For this one, this and this. For this one, for this one. So here so many paths are possible. Here no possible. Sorry. For this one, diagonal is this one. You can come like this. So many paths are possible. Out of these, shortest is shortest path. See, this is one way. This is one way. Out of these, shortest is represented with red color. Because only 2 pixels are connected. Red color is shortest path. Okay. Next, M path. M path. 101, 111, 110. Generally, if 4 path is possible, M path is possible because the first condition is Q belongs to N4 of P, right? If it is satisfied, M path is possible. So no need to check for another condition. No need to check for another condition. Right? This is M path. 2 paths are possible. 2 paths are possible. Next, connectivity. So connectivity is defined as again 4 ways. 4 connectivity. 8 connectivity. M connectivity. Okay. How can we define? So path, if 4 path is possible between P and Q, then P comma Q are 4 connectivity. 4 connectivity. If 8 path is possible between P and Q, then P comma Q are 8 connectivity. Okay. If empath is possible, empath is possible between P and Q, then P comma Q are 8 connectivity. Sorry, M connectivity. M connectivity. Okay. Next after connectivity, region. Region is nothing but group of pixels or some subset of image. Subset of image. Group of pixels or subset of image. Next, boundary, also known as border, or also known as counterpart. Okay. So border, when we called as border, means a region R is adjacent to complement of R, then we call it as border. Okay, then we call it as border. Okay. Next, edge means path which separates two regions are called edges. And last one is distance measure. So distance measure, 2 pixels, we have to find out the distance between these 2 pixels. We have to follow 3 conditions. First one is distance between them is always greater than or equal to 0. Next, PQ distance and QP distance both are same. Okay. And third one, intermediate pixel is there, suppose P comma Z. It must be less than like this. These conditions are must be satisfied. Okay, then we can calculate distance measure. In that, first one is Euclidean distance. Euclidean distance is given as d of P comma Q is equal to root of x minus s square plus y minus t square, where P is P x comma y position, Q is available at s comma t position. Okay, then the distance is given as like this, Euclidean distance. Next, D4 or city block distance. City block distance or D4 of P comma Q. It is given as mod of x minus 1 plus mod of y minus t. Okay. And last one is chessboard distance. Chessboard distance. D8 of P comma Q. It is defined as max of mod of x minus x comma y minus t. Okay, y minus t. Let us see a small example. So P is equal to 4 comma 1 at located at position 4 comma 1. Q is equal to located at minus 2 comma 3. Okay, 2 comma 3 position. Now calculate these four distance, 3 distance. So D of P comma Q is what? Root of 4 minus 2 whole square plus 1 minus 3 square. So 2 square minus 2 whole square, that is 4 plus 4, that is root 8. Okay. Next, D4 of P. D4 of P comma Q is modulus 4 minus 2 plus modulus 1 minus 3. So 2 plus 2, that is 4. Okay. Next, D8 of P comma Q. Max of modulus 4 minus 2 comma 1 minus 3. Both are 2 comma 2 only. So D8 of P is 2. Okay. These are the distance measure. So this is the most important topic in first unit, relationship between pixels.